Hello guys, welcome to my channel. My name is Obinna, and if today is your first time of coming to this channel, please subscribe and hit the notification button so that you get notified anytime I release an interesting content. So in today's video, I'm trying to start a series in microservices using Golang. We are going to build a very comprehensive microservice where we're going to interact between these microservices using gRPC. We are going to create a Docker image for these different services in this microservice. And we're going to manage these different microservices using Docker Compose. So it's going to be an interesting ride and a very advanced stuff that you are going to use in production, in your workplaces, or even in an interview scenario if you follow this course to the finish. So like I said, it's going to be built using Golang, and we want to create an application, a backend application, distributed application per se, because we're going to create different microservices. And then the application basically is going to be called an inventory service because it's going to allow users to create inventory, and then we're going to integrate a rating functionality into that inventory service so that users can rate that particular inventory or that particular inventory. So when I mean inventory here, I'm talking about product. So users can create a product, and then we're going to integrate a rating system into that product so that people can rate that particular product between 1 to 5. So this microservices or microservice backend is going to have three specific microservices. We have the broker microservice, the authentication microservice, and the inventory microservice itself. So the broker microservice is going to serve as the load balancer that receive the request from the clients, be it the postman or the front end application. So every request comes through the broker service that validates this request and forwards it to the individual microservice that is needed to be forwarded to. So when a user makes a call to the broker service, if it is an endpoint that requires authorization, the broker service forwards that request to the authentication microservice that validates that request and making sure that this user is authorized to make this call, and then send that response to the broker service, which then forwards that particular request to the inventory service that gives the user the authorization to create an inventory or to rate an inventory. So it's going to be a mini backend application built in a distributed format, in a microservice format, managed by Docker Compose. So you're going to encounter this in production environments, in your workplaces, or even an interview. So the icing on the cake is that the interaction between these microservices is going to be done through gRPC. So the client makes a call from the front end to the broker service using the HTTP protocol, but the interaction between the broker service, the authentication service, and the inventory service is going to be through gRPC. So it's quite an advanced stuff. So if you are new to Go and you find most of the things I'm saying quite strange to you or what I'm using, you are not out of line, you can go back and get to understand the basics of Go. So without wasting much of your time, let's dig in. So first of all, let me go to my terminal. Let me go to my documents and clear my screen and create a working directory. Let me call it tutorial. And then let me seed into tutorial and create a folder called broker. Remember, I said I'm going to create three microservices. These microservices are going to be individual applications. They are going to be individual applications, but they're going to interact with each other, right? And I'm going to manage them in Docker Compose file because I'm going to create Docker images for each of these repositories. So the first thing I said is I'm going to create a broker service that is going to serve as the load balancer that receives the request from the client. So let me make a directory called broker service. Let me call it tutorial underscore broker service. Right. So within this folder, let me make another directory called cmd. Let me make another directory called API within the cmd file, and within the cmd API, I'm going to create a file called main.go, handler.go, and routes.go, right? So these are the different files I've created. You can see them. So let me go back to the root directory of the broker service ls, right? You can see it. So I'm going to initialize this particular broker service or broker repository to use Go modules. Just like the way when you want to start a node application, you kind of initialize using npm init. So you are going to do the same thing for Go application. So how do you initialize a Go module in your intended Go repository or Go application? What you do is say go mode init, say github.com/obine, or let me call it like this because that's what I want to call it. You can call it anything you want, right? And let me call it okay, let me call it this. So this is how to initialize a Go module in your repository, right? You say go mode init, and then you give it whatever name you use. This name is generic. You can use anything, but I want to follow convention because that is conventional, right? But you can call it anything. You can call it ABC, you can call it John Doe, whatever, right? But you must have Go mode init, right? So I've initialized this particular repository to use Go modules. So I can then install Go packages now because I have a package manager Go mode installed in my repository. So this is a package manager for Go packages, right? Go mode. So what do I do next? Let me open this in Visual Studio Code. Right. So I have my broker repository and I have Go modules initialized. You can see it, and I have different files created. So this is going to serve as my handler file where all my functions will be created. This is going to serve as my entry point. Just like you have entry point for your node application, you always have an entry point for your Go application. So this file is going to also serve as my routes file where I'm going to write all my files, right? So let me kind of increase this a little bit. Right. So every Go application belongs to a package. So let's call it package main. Let's also call this file entry one package main, and the handler 2, let me call it package main, right? So I can still increase this, right? So we have this, okay, we have main, we have routes file, we have the handler file. So what I want to do, let me create a file, let me call it draw.escalidraw.json. So I have a plugin for escalidraw in my Visual Studio Code. You can find it in the marketplace and install it so that you can have escalidraw plugin and you can draw diagrams. So this is what I want to do. So I want to create an inventory backend that we have 3 specific microservices, which is broker service, authentication service, and the inventory service. Okay, so these are the things I want to create. So like I was saying, I want to have 3 microservices in my inventory backend. We have the broker service, the authentication service, and the inventory service. So what happens is that we have the broker service here. Let me call it BS, and then we have our auth service AS, and then we have another service called the inventory service itself. So the communication between these inventory services is going to be made possible between the broker service to auth service, from broker service to inventory service, and this communication is going to be done via gRPC. So every communication between this our application is going to be done via gRPC. Okay, so gRPC is going to be what the broker service is going to use to communicate to the authentication service and also to the inventory service. So assuming we have a user who is on their browser, right, somewhere here, and then we have a user here. So this is a user. Okay, so the user makes a call to our backend application. The request gets to the broker service, which then validates the call or the request, and then forward it to the appropriate service via gRPC. So this is the summary of what we're going to do. So many things that we're going to use here will include, we're going to use things like gRPC for communication between microservices. We're going to do Docker Compose to manage our Docker images for this microservices. So we're going to create Docker images for these different microservices and manage it using Docker Compose, right? So this is a very, very good stuff and quite advanced in my opinion. So let's continue. Let's go back to our inventory. Our broker service. We have the handler file, we have the main file, and we have the routes file. So what happens is that every application have in Golang have an entry point, which is basically the main function. So you can say func main. So all calls will pass through this func main, right? So we have this here, and then let's create another function called so anyway, before then, let me create something here, a type config of a struct of type config, right? So if you don't know what is a struct, a struct is like an object or a blueprint, you can call it that way, that can associate variables and functions to, just like the way you have classes in other programming language. Okay, so let me come to routes, my routes file. I'm going to install, I'm going to use Chi router for routing in my Go application. So it's going to manage our routing. So let's go to our browser and then let's find Chi. So I already have it open here. So how do I make use of Chi? Let's say this is the course package. Okay, so you come to this particular GitHub repository. So this is going to manage our routing. So what does it do? Chi is a lightweight, idiomatic, and composable router for building Go HTTP service. So this is our router for building our routing file or routing in our Go microservice. So let's continue. Right, so how do you install it? So cd tutorial, so you say go get, so it's already there, so I can delete this and then I just say go get. So that's how to install packages. Good. So what else do I need to install? Let me install a middleware. I may need it later. Go get, right? And then what do I need to install again? I may need to install course. Let's look for course. All right. Of course, you know what course is. It's a middleware that allow cross-origin requests between services that are not on the same server. So let me install it. So I've installed like 3 packages: the course, the middleware, and the Chi router itself. So let's continue. So within our routes file. Let me create a function and associate it as a receiver to config. So you may not know what is a receiver because this is advanced stuff. I think along the line I'm going to create a tutorial to explain the basis of Go, things like interfaces, things like structs, things like pointer, things like references, things like structs, right? So I'm going to explain this maybe using another video, but not this video because this is straight to the point, right? So but if you want to follow, you can follow along and then arrive at the same result. So we are creating a function called routes and associating it to the type of config struct. And then how do we make use of how do we create routes in Go? So let me call it R, and then let's say, so we install Chi. Don't forget Chi. So you create a new object, right? So how do you now enable calls in Go? So let's enable calls. Let's go to the package we installed and find calls. So this is how to enable calls. So this is quite a lot, and you can see you say R use calls handler calls option, allowed origin. You can see it, you allow HTTPS and HTTP requests. You also allow method get, post, put, and you also require authorization and your content type, and allow credentials for. So this is how to enable calls. You can decide to remove or add any particular options you want here. So let me just copy this and make use of it in our route file, right? Good. So how do we now create a route? You can say r.post because we want to create a user. So let's say alt service / create user, and then we now say app.create user. So this function is not yet available, but we are going to return R. So we are returning the objects that we created here, right? So let's go back. So this particular route file is supposed to return http.handler, right? So this is from the net/http package. So we've created our route file. So what do we do next? Let's create this function in our handler. So in our handler, I can say func associated to the config struct, and then what do we call it? Create user, and it accepts two parameters: a response writer and a request, which is a pointer to http.request. Okay, so you can see we've created our function and then our routes, but we are not making use of the routes yet because we are yet not making use of it. So for us to use it, we have to go back to our main function, right? So to make use of the routes, so let me just start. Let's say log.println. Let me say starting broker service, right? So we are going to define our HTTP server, and then we are going to start listening on a specific ports. Start, serve, and listing, right? Start, serve, and listing on a specific port, right? So let's call the port. Let me say const. Let me make it a constant. Let me call it web port. Let me make it port 88, right, for our broker. So how do we start a server, or how do we define a server? Let me call it variable srv, and let me say it's a reference to the net.http package that's .server, right, that accepts two parameters, right? When you go to this, you can see it accepts two parameters, address and a handler, and we've already defined our handler, which is this, in our routes file. And what else does it accept? an address. Okay, so it accepts an address. You can see it's auto populating, so I can say fmt dot printf, and then percent %s because it's a string, and then web ports, right? What else does it accept? It accepts handler. And what's the handler? App dot routes, but we are not yet, we don't have access to app, right? So how do we have access to app? So let's say app is going to be equals to a reference to our config. Don't forget that we associated the routes to the config struct. So because we've associated it, we are not able to access it via this config struct. So I'm creating an instance of the config struct so that I can access all the functions that are associated to it, right? So you can see this no longer give me error because I'm able to, from this instance, access the routes here. Okay, so these advanced stuffs. So we can then start serve and listen to our server, our web port, right? So it's going to return an error if it fails. So srv, that will be it's going to be srv listing and serve, right, which is going to return an error if it fails. So if error not equal to nil, so let's log, it's a log.println. Let's see what is the error, right? So I can say log.println starting broker on port, let me say web ports, right? All right, so we've created our simple HTTP server on our broker, and then we've created our routes that has one handler, which is the create function, right? And then we have our main handler, our routes, and the handler itself. So let's start this and see if it works, right? So how do we start it? Let's go back to our function. Let me clear. So in our CMD, we have all the files that we've created. So how do you run a Go application? You say go run, let's say main.go, routes.go, and handler.go. So we have an error. What is the error? So this is quite important. So routing pattern must have a slash. So let's go to our routes and then correct the error. So let me set error. Let me add the slash here. That's the error. So let's go back, clear, and rerun. So this is a cumbersome way of running this application. Go, we are kind of specifying all the files we have here. So we are going to refactor this thing, but this is just the basic to get things off the ground. Okay, then you refactor. That is what makes you a good engineer. Let's run it again. Right, you can see broker service, broker, starting broker on port 8080, just like we've defined here in our main function, right? You can see starting broker on port 8080, right? So now it's not going to do anything if I make a call to this particular backend. So let me create a folder. Let me create a folder between these. Let me call it broker. And then within this broker, I'm going to create a request, create user. Okay. And then let's make it post request. Nothing is going to happen. Okay. What is the request here? We say it is right, and it's supposed to have a body JSON. So because we want to create a user, so let me say name, let me call it Obina Williams, right? And then email, let's say William at abc.com, right? And then when we make this request, okay, so let's correct this. So nothing happened, it doesn't return anything for us because of course we are not returning anything. So let's go back to our handler and try to return something. So I'm going to create a type, let me call it type response, and let me call it okay, let me say type user of struct, okay, which is a struct, and it's going to return a name, right? It's going to return a name, and it's going to also return an email for us, right? So this name is type string, and it's going to be JSON of type name, right? I think that is the way it is. And then we have string and JSON of email, right? So if I want to return, I can say return a reference to user, you can say name, let me call it William James, and then email, let me call it will at abc or abd.com, right? So but this is not going to work for us, right? So why is it not going to work? Because the way we return a response in Go, we use our response writer. Don't forget we have a response writer defined, so we're going to use our response writer to return our requests to the user. Okay, so how do we do that? So when you go to this response writer, it has a lot of function. You can set the header, you can set the right what you're sending out, and you can set the status. Okay, so let's do that. So to return this user, let me call this data. Okay, so this I want to return data to the calling method to the client. So what I can do is I can set the header w header. So and then let's say dot set, let's set the content type. Okay, and what should be the content type? The content type should be application JSON, right? Application / JSON. And then what do I do again? Let me give it a status. Let me say right header, another right header, and then we'll give it a status. Let's say http dot status accepted, or let's say status okay. Okay, and then we can then then write. Okay, we can then say w.write, and then we'll give it what we want to send out. So we are passing data because that's what we want to send, right? So that's what we are sending. So if error not equals to nil, we can then let's just return the error, or else we say return new, right? So maybe we can then we can just log it. Let's log it, log.println error, and then I need to return new here because it's already returning. Okay, so this is the data we want to send out, but is what are we having here? So we have to kind of we kind of need to marshal what we want to pass, right? We have to marshal it. So how do we marshal it? We have to convert it to a JSON representation, or maybe byte representation. Let me call it a byte representation that is going to be sent to the user. So how do you do that? You say, let's call it out, and then let's say we have error, and then let's say JSON dot marshal, let's marshal data, and then we can then pass out to it. So this should no longer have this, right? And then if we have error here, not equal to new, let's just log the error just like the way we are logging here. Okay, right? So now when we make a call from our postman to our backend, it will return this particular information. Okay, so let me stop the server and start it again to make sure there's not any error. So there's no error, so we hope that this should be successful. So let me make the call again. Correct. So you can see our broker microservice is working perfectly well. So we're able to start a simple server in our broker microservice. So the next thing I'm going to do is to create a simple server for the authentication service and also for the inventory service. We're going to follow the same steps that I followed to arrive at this. So, but we are going to start it on a different port just to test it out. This is running on port 88. Maybe the authentication service is going to be on port 8081, while the inventory service is going to be on port 8082, just for us to test and be sure that we are reaching that microservice. When we now want to implement our gRPC, we will no longer need this specific port because all requests will no longer be accepted from a client outside. The only microservice that will be connected to the public will be the broker, so that when a user makes a call to the broker from their client to the broker can then make communication to those different microservices. You will no longer be able to directly from the public access the auth service or the inventory service. So that will be the next thing we are going to do. I'm going to create the same thing that we did here for the inventory service and for the authentication service. I'll be very fast in doing that because this took a little bit of time so that we all understand what we are doing. So in doing that, we will now have 3 working servers, and then we can then build upon it.